This week's topic is groundwater, and I'm here in Centennial Parklands, the site of the field trip. And this is Busby's Pond, named after the engineer that tapped into the groundwater resource here to supply the early European settlement. Groundwater is our largest freshwater source on the planet that is accessible. But we need to know how to manage it sustainably if we're going to use it into the future and for future generations. That's what you'll learn this week. Hello, GEOS adventurers. So this week's topic is groundwater. And what is groundwater? Groundwater fills the pore spaces and fractures in the subsurface. And it makes up 99% of the liquid fresh water on planet Earth. So that's the fresh water that excludes water frozen as ice, predominantly at the poles. And it's a hidden resource because it's not visible. It's not apparent to people going about their daily lives on the Earth's surface. And because of that, it's widely misunderstood or poorly understood. Groundwater originates as precipitation that falls on the Earth's surface and which infiltrates through the soil. And you understand that from the soil hydrology topic in the previous weeks. It can also originate from leaky rivers, lakes and reservoirs. So these are water bodies which are situated above the groundwater level, and therefore water can leak from the base of them and supply the groundwater system. A groundwater aquifer is the subsurface geology that is saturated with water. The top of this saturated body is called the water table, and you can see that labelled on the figure on the right hand side. And above the water table and below the land surface is the unsaturated zone. Where the water table intercepts the land surface, you'll find surface water bodies. These will be wetlands, lakes, rivers and streams. And you can see that example on the right hand side. And you can see the picture also shows two types of water storage in the subsurface, through the fractured rock, which is on the left hand side, and through the pores between sands and gravels on the right hand side. Why are we considering groundwater? Why is it important? Firstly, and as I said in the previous slide, groundwater is important as it is the largest source of liquid fresh water. And you can read more about that in the explainer provided in the link here from an article in The Conversation. And we need fresh water to survive. So we can only survive 3 days without fresh water because we need water to help regulate our body temperature. Water acts as a solvent in our bodies, allowing oxygen to be transported around, which is essential for life. And for any drugs, for example, that we may take, many medicines, it allows them to be mobilized because they're soluble. It maintains our cell structures and it buffers our body from the effects of acidic and alkaline molecules. Here in Australia, groundwater makes up about 17% of the accessible water and accounts for more than 30% of the total water consumption. Our largest groundwater resource, shown on the right hand side, is the Great Artesian Basin. That covers 20% of our landmass and holds about 130,000 Sydney harbours worth of water. So a Sydney harbour volume equivalent, 130,000 of those is the total amount of water in the Great Artesian Basin. But in general with groundwater, the question is it managed or has it been managed sustainably in the past? Have we over-abstracted the water and our groundwater levels falling? And in many places we have also polluted the groundwater, and that's often hard or impossible to remediate. It is polluted, it's less likely to be drinkable, and there's likely to be a useful source of fresh water. A second reason for why groundwater is important is that it has an economic value. I mean, this is particularly important here in Australia. So groundwater has been crucial for the survival and the prosperity of the First Nations people. It was also crucial for the European settlers who were dependent on groundwater to actually expand out from the early settlements into the countryside. And it's still an essential water source for much of regional Australia. But as I mentioned in the last slide, it needs to be unpolluted and it needs to be sustainably managed. So we mustn't have significant groundwater level declines so that we are going to run out of groundwater in the future. You can find many different values, economic values for groundwater. I've selected some here. So for example, a figure from 2013 was that groundwater was worth 6.8 billion Australian dollars of GDP equivalent to the Australian economy. Since 2017, the New South Wales government has invested more than $3 billion of drought relief for farmers and rural communities and town water security projects through drilling new bores. So that was in the last drought. And groundwater use increased dramatically over the course of the Millennium Drought and accounts for more than 70% of irrigation water across the Murray-Darling Basin. If you're interested in the economic value of groundwater, and in particular to New South Wales, the New South Wales government has an excellent video, the link for which is on the right hand side. And thirdly, I hope I've made the case that groundwater is an essential resource, but also one that is finite, and that we need to understand groundwater processes. Then we can better manage our groundwater resource and manage it sustainably. And we have some serious challenges to groundwater. The first is the over-abstraction of water for things like drinking water supply, for agriculture, irrigation, and for manufacturing industries. There are also challenges over the contamination of groundwater. I've just picked some selectively here. In large parts of Southeast Asia, drilling of new boreholes has accidentally led to the mobilization of naturally present arsenic, leading to an arsenic pollution problem. In many parts of the world, the over-application of fertilizers has led to nitrate pollution. In many urban areas, we have leaky landfills and leaking sewage systems. This has led to organic pollutants, pollution plumes entering the groundwater system. And often we have leaks and spills in industrial areas and urban areas. They could come from service stations. And these all lead to more localized pollution. And the final challenge is changes in the water budget due to climate change and to land use change. And we need to understand how they will affect the sustainable management of groundwater. There's a very nice schematic on the right hand side from the Groundwater Foundation that summarizes many of these different pollutants and risks to groundwater. What is happening in class this week? We'll be going to see the groundwater, and that is going to be through a field class to Centennial Parklands, where we will investigate the Botany Sands Aquifer. The aim of the field class is to strengthen your understanding of our groundwater resource through a case study of the Botany Sands Aquifer. And your learning outcomes include observations of groundwater recharge zones and groundwater springs. You'll observe surface lakes and understand how they can be surface expressions of the groundwater table. You'll observe some sources of groundwater pollution and how it's remediated. And finally, you'll explore the history of groundwater abstraction from the aquifer and find out how to obtain modern day groundwater level data. So what do you need to do before the field class this week? On the right is your resource. It's a book by Eileen Porter et al., Groundwater in Our Water Cycle, and it's published by the Groundwater Project, based in Canada. And I'd like you to have a good understanding of the fundamentals of groundwater and how that relates to the modern day landscape. And that information is contained in Chapter 3 and Chapter 4, Parts 1 and Part 2. And that's what I'd like you to read. So when you read those chapters and sub-chapters, please focus on understanding the definitions that are provided in bold. They are the key fundamental terms that you do need to understand. And Chapter 3 gives you an introduction as to how groundwater is part of the global hydrological cycle. And Chapter 4, Part 1 and Point 2 explains some of the relationships between groundwater and surface water features, such as springs, rivers, and lakes. And these are some of the things you're going to see in the field. To recap then, and what you need to understand before the field class this week, I would like you to understand the definition of the groundwater terms. Terms such as, what is an aquifer? What is the water table? What is the unsaturated zone? I would also like you to be understanding of the role of groundwater as part of the global hydrological cycle. And I'd like you to understand the relationship between groundwater and surface water features. For example, rivers that lose water, rivers that gain water, springs, those sort of features. So I hope you enjoy the reading, and I look forward to seeing you in the field class.